Lesson 2.2 is area of a triangle formula and applications of right and non-right angled trigonometry. So back in the day, we learned that area of a triangle is 1/2 base times height, but that's only really useful if you know the height or you have a right angled triangle, which is not very often. So now we have a formula for non-right angled triangles, specifically side angle side triangles. So if you have a triangle where you know two sides and the included angle, then the area is 1/2 the two sides multiplied by each other times sine of the angle. So depending on which set of letters you have, it could be 1/2 AB sine C, or BC sine A, or AC sine B. So again, this is when you have a side angle side triangle. So for this first example, a farmer owns a triangular plot ABC where length AB is 120 meters, BC is 240 meters, and the included angle, angle B, is 130 degrees. So go ahead and find the area of this plot to the nearest integer. So this is just straight side angle side area of a triangle formula. Area is equal to 1/2. In this case, the letters that we have are AC sine of angle B. So I plugged in 120, 240, and 130 degrees and got the area is 11,031 square meters. For this next example, they give us the area of this triangular plot to be 29.6 square centimeters and angle B to be 25 degrees and side BC to be 7 centimeters. So go ahead and pause the video and find length AB. So in this one, they gave us the area and they want us to find the missing side. So I set our area equal to our area formula. We have a side angle side triangle, so we have 1/2 side A, which was 7, side C, which is what we're solving for, times the sine of angle B, which is 25 degrees. Then I divided both sides by 1/2 7 times sine of 25 degrees, and got that our missing side is 20.0 centimeters. So on this one, we have a parallelogram ABCD with BC being 7.4 centimeters, and AB being 12.3 centimeters, and angle B being 39 degrees. So go ahead and pause the video and find the area of this parallelogram. So the way that I did it is I found the area of triangle ABC, and then I just doubled it because these two triangles inside the parallelogram are going to be congruent. And we have a side angle side triangle, so the area would be AC sine of B, where A is 7.4, C is 12.3, and angle B is 39 degrees. So the area of triangle ABC would be 28.640371 centimeters squared. And then again, I just doubled that to get the area of the parallelogram and got that to be 57.3 centimeters squared. So based on this, you could know that the area of a parallelogram, if you have two sides and the included angle, would be AB sine C, where A and B are your two sides and C is your included angle. So in example number 4, we have a roof in the shape of an isosceles triangle. So remember, an isosceles triangle means that two of the sides are the same. In this case, PQ and RQ are congruent. And they give us that angle P is 61 degrees, and this base side here, PR, is 12 meters. So given this information, we have some missing information that you'll have to find first. Go ahead and pause the video and see if you can find the area of triangle PRQ. So in order to find the area, we need to have a side angle side triangle, but right now we have an angle side angle triangle. The reason that we have an angle side angle triangle is because this is isosceles. That means your two base angles are congruent. So if angle P is 61 degrees, then angle R is also 61 degrees. So we need to make this into a side angle side triangle in order to make this able to find the area. So you have to find one of your missing sides, which they're congruent, so they're the same thing. So right now we have an angle side angle triangle, which is my law of sine. So I set up my law of sines. I found our missing angle, angle Q, to be 180 degrees minus 2 times 61 degrees, which would be 58 degrees. And then I solved for one of the two missing sides. They're congruent, so it actually doesn't matter which one you solve for. And you get R over sine of 61 degrees is equal to 12 over sine of 58 degrees, or multiply both sides by sine of 61 degrees, R or P, either one, to be 12.37599,204 meters. So now you have a side angle side triangle. If you haven't already done so, go ahead and pause the video and find the area. So no matter what, we have all our missing sides and missing angles, so you could use any combination of two sides and the included angle. I chose side R, angle P, and side Q, so I did 1/2 R times Q times angle of P, so 1/2 12.375 times 12 times the sine of 61 degrees, and got the area to be 64.9 square meters. Next example, it says find the area of a triangular vegetable garden with sides 15 meters, 7 meters, and 12 meters. So go ahead and pause the video and try this one. So on this one, we have a side, side, side triangle. We need to have at least one angle. So side, 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 that's the law of cosine. So I just found angle A. You could have found any of the three angles. You ended up with a squared equals b squared plus c squared minus 2bc cosine A. So I plugged in 12 for A, 7 for B, and 15 for C. So you get cosine of A is equal to 7 squared plus 15 squared minus 12 squared over 2 times 7 times 15, or 130 over 210. So switch into inverse trig to solve for the angle. Angle A is equal to cosine inverse of 130 over 210, or 51.7533812 degrees. So now I found this angle here. I have a side angle side triangle. Now we can use our area formula. So for the letters that we have here, it would be 1/2 BC sine A, where B is 7, C is 15, and angle A is that angle that we just found. Plug all that in, plug it into your calculator, and you should end up with 41.2 square meters. So this next example, a floor of a gazebo has the shape of a regular octagon, so 8 sides, with the side length to be 1.2. If it's regular, that means that it's congruent. All of these are congruent, and is made up of 8 congruent triangles, and we want to find the area of the floor. So a hint for regular polygons, the central angle is 360 degrees divided by how many triangles you have. So go ahead and pause the video and try and find the area of this floor. So the central angle would be 360 degrees divided by the 8 triangles. So each of these angles would be 45 degrees. And then since this is an isosceles triangle, because your radii are congruent here, I know that to find these two angles, it would be 180 degrees minus 45 degrees. And then divide that by 2 would be both angles A and B. So angles A and B would be 67.5 degrees. So now I have an angle side angle triangle, which is the law of sines. And you can use that to find your congruent sides here, either A or B. So I solved for side A over sine 67.5 degrees is equal to 1.2 over sine of 45 degrees. Multiply both sides by the sine of 67.5 degrees, and you get these congruent sides here to be 1.5678, so on and so forth. Now we have a side angle side triangle, so I looked at the two congruent sides and the angle between them with this central angle here. And you get the area to be 1/2 this side squared, because you're multiplying it by itself twice, times the sine of 45 degrees. So the area of one triangle would be 0.86911688825 square meters. And there's 8 congruent triangles, so I multiplied that by 8 and got the area of the floor to be 6.95 square meters. The last part of this is area of a sector. So we talked about arc length back in 1.6. Sector is the section of the circle where arc length is the part of the circumference here. So arc length is the circumference, the section of the circumference. Area of a sector is the area of that chunk of the circle. So similar to arc length, where you're taking a piece of the circle, your area of a sector is going to be theta, whatever that interior central angle is, divided by 360, because you're just taking a part of it, times the area of the circle, so times pi r squared, where r is your radius, and again, theta is this central angle. So given this crop sprinkler here that irrigates a circle with radius 5 meters, find the area of sector BAC with a radius of 5 meters and a central angle of 120 degrees. So go ahead and pause the video and try that. So just plugging in theta to be 120 degrees, because that's your central angle, and your radius to be 5, you should end up with 26.2 square meters. So on example number 2, it says the area of the sector BAC has a radius of 13 centimeters and the area is 30 pi centimeters squared, and we want to find x, which is the central angle. So go ahead and pause the video and find x. So the area of a sector is theta divided by 360 times pi r squared. In this case, theta is x, so that's what we're solving for. R is 13, and our area is 30 pi. So I set that up. 30 pi is equal to x over 360 times pi times 13 squared. And then I multiplied by the reciprocal, so I multiplied by 360 and divided by 169 pi to cancel off everything except for the x. So I did that to both sides. The pi's cancel, and you're left with 63.9 degrees. The last example says sector AOB has radius 4 centimeters and central angle 75 degrees, and we want to determine the area enclosed between the chord AB and the subtended arc. So basically we want to find the area of this green shaded area. So go ahead and pause the video and try that. So for this last one, if you look at the shaded area, it's the part of the sector that's not inside the triangle. So I found the area of the whole sector and the area of the triangle and subtracted them. So the area of the sector is theta over 360 times pi r squared, where your central angle is 75 degrees and your radius is 4. So you get the area of the sector to be 10.5. And then the triangle, you have a side angle side triangle. I did the 2 radii, and then your included or your central angle. So you have 1/2 times 4 times 4 times the sine of 75 degrees. So you would get about 7.73. So then the green area is the area of the sector minus the area of the triangle. So you end up with 2.74 square centimeters. So this has been area of non-right triangles and area of sectors.